This is homework 6.3, solving system of equations using Cramer's rule. So the first thing we want to do for all these problems is to find the determinant of the x, y, z portion of the system. To do that, we're going to rewrite these coefficients as a 2 by 2 matrix. So -3, 1, 2, 1. That is our matrix A. So for the determinant of that, we would have -3 times 1 minus 2 times 1, which gives us -3 minus 2, which is -5. To get the solutions, we're going to start replacing the rows with, the columns with the answer column. So we, for A1, replace the first column with the answer column for -6, and then we have 1, 1. And then we're going to find the determinant of this. So our first cross there is 4 times 1 and minus -6 times 1. So we have 4 minus -6, which is 10. So the first solution is that determinant divided by the overall determinant. So we get -2. And then for A2, we replace the second column. And we find the determinant of this. And just like before, we take that and divide it by the original determinant. And we get 2. So x is equal to the first solution we found, which was -2, and y is equal to that second solution we found, which was +2. I made a slight mistake. That was supposed to be -6 up here. So this is -6. -6, +18. 18 minus 8 is +10. So the solution is -2 for y as well. So my mistake there. So our solutions should be both -2, -2, -2. Okay, moving on to 14, same process. It's another 2 by 2. So we start by taking the original matrix A, which is just the coefficients of the x and y. So 5, 4, -1, -4. We'll find the determinant of that matrix A. So we have 5 times -4 minus -1 times 4. So we get -20 minus -4. So that's -16. So that's plus a +4. So we get -16 for the determinant for A. For A sub 1, we're going to replace the first column of A with the solutions 7, -3, so 4, -4. So the determinant of A1 will be 7 times -4 minus -3 times 4. So that's -28 minus -12, which should give us a total of -16. Which makes our solution -16 divided by -16, or 1. For A2, we replace now the second column with the 7 and -3. We find that determinant, so that will be 5 times -3 minus -1 times 7. So we have -15 minus -7, which will give us a positive, -8. So the second solution, A2 over A, is negative 8 over negative 16, or 1/2. So our two solutions for x, the first solution was 1, and the second solution here for y is 1/2. For number 14, again, another 2 by 2 to start for a. So it's 4, 1/3, 3, 1. And the determinant of that will be 4 times 1 minus 3 times 1/3. So we have 4 minus 1, or 3. So a sub 1 is going to be 8, 6 in the first column, 1/3, 1. And the determinant of that will be 8 times 1 minus 6 times 1/3. So we've got 8 minus 2, which is 6. So the first solution, a1 over a, the determinants will give us 6 over 3, which is 2. For a sub 2, we will have 4, 3, 8, 6. So when we do the determinant of a2, we have 4 times 6 minus 3 times 8, which is 24 minus 24, which is 0. So the a2 solution will be 0. So it's okay to get a determinant of 0 at this stage, as long as we don't get a 0 determinant for the original. They did give us in the instructions for this, find the solutions if they exist. All the homework problems, they do exist. The only time that the solutions, the systems would be unsolvable is if the original determinant was 0. So if a, the determinant of a was 0. Here it's just a2, so that's fine. That just means our y solution is 0. Now we've got a three equation system. So this is going to be a little bit more challenging with the determinants to do a 3 by 3. So we're going to go through that process again to make sure that we've got it all down. So what we want to do to start for a is still rewrite the matrix as the coefficients. So we've got 1, 1, 1, 6, negative 2, negative 1, 3, 4, 2. That is our matrix A. Now to get the determinant of that, we need to take that and recopy it exactly right next to it. And then 3, 4, 2, 3, 4, 2. So I'm going to use a little bit of highlighting here. I probably should have did this on the original notes. The diagonals, when we go the first way, these should all be the sign that they are. So these are all, whatever the math works out to be, you keep that sign. When we do the other set of diagonals, so we go the other direction, these blue diagonals, those should be, it's probably not the best color to use when I've got blue writing, so let's try yellow. So these yellow diagonals, those should be the opposite sign. So if it comes out as negative, then it needs to be changed. So the pink highlighting there is the same sign. The yellow highlighting should be the opposite sign. Okay, so let's take a look at this. We've got 1 times negative 2 times 2, so that should be negative 4, and we keep that same sign. Then we have 1 times negative 1 times 3, so that's negative 3, keep the same sign, and then 6 times 4 times 1 is 24. And they all stay that same sign that they were when we did the math. Okay, and now for the yellow, we'll have 4 times negative 1 times 1, which gives us negative 4, but we're going to make it the opposite sign, so it actually becomes positive 4. And then 2 times 6 times 1, that's 12, but we make it the opposite sign, so it's negative 12. And then 3 times negative 2 times 1 is negative 6, but we make it the opposite sign, so it's positive 6. So we do 4 minus 12 plus 6 minus 4 minus 3 plus 24. And we end up with 15. So the determinant of A here should be 15. Okay, so we just need to make sure that we are making the numbers the correct sign when we do this. Otherwise, our determinant will be wrong and the whole problem will be wrong, and you'll get some nasty answers. For A1, we are going to replace the first column with the answer column 12, 16, 28. And then it'll still be 1, 1, negative 2, negative 1, 4, 2. Same process for finding the determinant of this new A1. We are going to copy this again exactly. So we have 16, negative 2, negative 1, and then 28, 4, 2. Okay, so I've got my calculator here. These are going to be a little bit bigger just to save some time. I'm not going to do these in my head. So we have that. And I think I switched colors, but whatever, you get the idea. Okay. So we have 12 times 4, which is 48, and it's negative 48. Same sign there. Negative 28. And then 4 times 16 is 64, and it's positive. Okay. 4 times 12 is 48, negative 48, but we make it the opposite sign, so it's actually positive 48. 2 times 16, that's 32, but we make it negative 32. And then 28 times 2 is 56, negative 56, but we make it the opposite sign, so it is positive 56. Okay. So let's add these up and see what we get. So we have 48 minus 32 plus 56 minus 48 minus 28 plus 64. And hopefully it's divisible by 15. It is 60. Okay, that's good news. So A1 is 60, which means our first solution is 60 divided by 15, which is 4. Okay, and then we move on to A2. So A2, we will go back to the first column we had, so 163. Then we have 12, 16, 28, and then 1, negative 1, 2. So make our copy here. 1, 12, negative, oh no, positive 1. Let me rewrite all that. 1, 12, 1. Okay, 6, 16, negative 1, 6, 16, negative 1. 3, 28, 2, 3, 28, 2. Okay, so 16 times 2 is 32. 12 times 3 is 36, so negative 36, and 6 times 28 is 168, positive 168. Okay. So then we have 28 times negative 1, which is negative 28, but we make it positive, so opposite sign, so 28. 2 times 6 times 12 is 144, but we make it negative. And 3 times 16 is 48, and we make it negative. So let's see what we get. 0. Okay. So A2 is 0, which means our second solution is 0, and that is totally acceptable in these. As long as the original was not 0, then we're in good shape. So now we are back to this. This is now 12, 16, 28, and that middle column was 1, negative 2, 4. All right. So we make our copy for the determinant. So A sub 3's determinant will be 1, 1, 12, 1, 1, 12. 6, negative 2, 16, 6, negative 2, 16, 3, 4, 28, 3, 4, 28. So that is negative 56, positive 48. That's 12 times 6 times 4. So 288. And then we go the other way. Where are we? Where are we? So this 1, 28, 6, and 1. There we go. It's 168. So it's opposite sign. So negative 168. Negative 72, but it's going to be positive 72. Oh, I got all my numbers messed up here. This is what happens when you don't write very good. So the 28, 6, and 1 was 168, negative 168. Then it's 3 times negative 2 times 1, so it's positive 6, and then it's I'm all sorts of messed up here. What is going on? Okay, I don't know what I'm doing. Okay, let's make sure that that's correct. So we've got 144 minus 168 minus 64 plus 288 plus 48 minus 56. That's 192, so that doesn't seem correct. All right, so let me rewrite this and go back and try to fix it. Sorry. Okay, I feel like that's what we had before, but let's just check this out here. So minus 168 minus 64 minus 56 plus 48 plus 288. That looks better. Okay, so the determinant of A3 is 120. So we have that over the original determinant, so 120 over 15, and that should be 8. Yes, okay. So there we go. Our solutions were x equals 4, y equals 0, and z equals 8. That's what happens when you try to rush through it and you get sloppy. You mess things up. Okay, for our final one here, we're missing a letter in each of the equations. So we don't have a z, we don't have an x, we don't have a y. So all we have to do is leave the placeholder blanks. So 9, 7, 0, 8, oops, that's 0, 8, 5, and then negative 3, 0, 10. So the determinant of A is 9, 7, 0. So this is going to make things a lot easier for us because we've got all of these zeros. So we're going to get a lot of zero products, which will make our determinants a lot easier to find. Okay, so here's what I mean. This first one here, we do have 9 times 8 times 10, so that's a big number, 720. But then we're going to get a 0 all column there. So 7 times 5 times 3, that's negative 105. And if we go the other way, we're going to get a zero there, a 0 there, and a 0 there. So those are all zeros. So we just have 720 minus 105. Okay, so 615. It doesn't feel right. We'll take a look and see what we're going to get out of this here. but everything's written in the correct spot. So let's take a look. A sub 1, we're going to replace this with negative 30, 11, and 73. And I'm just going to go ahead and save some time and not rewrite the matrix. So our middle will be 7, 0, 8, 5, 0, 10, negative 30, 7, 0, 11, 8, 5, 73, 0, 10. So we have 30 times 8 times 10, so that's negative 2400. Okay, so that 615 is not looking too terrible now. 7 times 5 times 73, which is 25, 55. And then we have 0, 11, 0, and then we have 0. We've got 10 times 11 times 7. Would have been positive, so we make it negative 770. And then we've got a 0 there. So we have 2555 minus 2400 minus 770. So we get negative 615. Hey, that's nice. So our solution here is negative 1. And for A2, again, we're going to save some time. We're just going to write the determinant portion. So negative 30, 11, 73 is now the second column, and then we have 0, 5, 10. So 9, negative 30, 0, 0, 11, 5, negative 3, 73, 10. So 9 times 11 times 10 is 990, positive. 30 times 5 times 3 is also going to be a positive, so 450. This is a 0. 73 times 5 times 9, and it's going to be a negative 3285. That's a 0, that's a 0. So we have 990 plus 450 minus 3285, which is negative 1845. And if we divide that by the original determinant, it should be negative 3. Okay, so we had these crazy big determinant numbers, but they're all giving us simple solutions, so that's nice. And the middle column is back to 780. So we have 9, 7, negative 30, 0, 8, 11, negative 3, 0, 73. So we get 50 to 56, that's a big number. We get 7 times 11 times negative 3, so negative 231. That's a 0, that's a 0, that's a 0. 3 times 8 times 30. So it would have been positive, so we changed the sign, so it is negative 720. So we have 52, 56, minus 231, minus 720, 4305, which is 7. So I was very nervous at the start of that problem because we had such a huge determinant at 615, but it worked out that all the other determinants of the rearranged matrices were also very, very large. So they all divided out and they were all nice, clean answers. So that should be a takeaway from this, is they gave us all these determinants and they got increasingly more difficult, but all the solutions were nice whole numbers. So the book has a way of kind of making these a little bit better for us by giving us those whole number solutions, even though the determinants are a little crazy. But that covers everything. If you had trouble doing the determinant method, getting those determinants correctly, especially with the 3x3 and the changing the signs, please go back and retry those to make sure you're getting them correct.